G'day you mob, Pete here, and this is another episode of Aussie English, the number one place for anyone and everyone wanting to learn Australian English. So today I have a Goss episode for you where I sit down with my old man, my father, Ian Smissen, and we talk about the week's news, whether locally down under here in Australia or non-locally overseas in other parts of the world. Okay, and we sometimes also talk about whatever comes to mind, right? If we can think of something interesting to share with you guys related to us or Australia, we also talk about that in the Goss. So these episodes are specifically designed to try and give you content about many different topics where we're obviously speaking in English and there are multiple people having a natural and spontaneous conversation in English. So it is particularly good to improve your listening skills. In order to complement that though, I really recommend that you join the podcast membership or the academy membership at aussieenglish.com.au, where you will get access to the full transcripts of these episodes, the PDFs, the downloads, and you can also use the online PDF reader to read and listen at the same time. Okay, so if you really, really want to improve your listening skills fast, get the transcript, listen and read at the same time, keep practicing, and that is the quickest way to level up your English. Anyway, I've been rabbiting on a bit. I've been talking a bit. Let's just get into this episode, guys. Smack the bird, and let's get into it. This is an oldie, but a goodie. So there was a
cliche watch.
There was a huge mouse plague in.
Oh yeah, that's an old one, but it's still going.
Yeah, is it?
So yeah, that was southern New South Wales, Riverina.
Southern New South Wales and South Australia, I think. It was crazy. So it was really interesting. There was an article on The Guardian, I think, called Drought Fire, the COVID-19 pestilence, and an all-consuming plague of mice.
Yeah.
So it was, they likened it to these biblical events, obviously, as a result of these plagues and fires and all this stuff that was happening. But it was just crazy, some of the footage that was coming out where you had thousands, maybe, hundreds of thousands of mice just ripping through fields and eating up everything.
Millions it would be.
Including themselves. Well, yeah, sorry, but in the footage itself.
Oh, right, yeah.
So it's been happening for several months, and it was in, rural New South Wales and southern Queensland following a bumper crop. So they obviously had a lot of rain last season, and that led to a lot of,
spring rain. Yeah.
A really good season this year for growing the crops. And, excuse me, as a result, the crops and the rain allowed mice to reproduce like crazy and get into plague proportions. So there were people waking up to mouse droppings on their pillows. They were being bitten by mice in the night. They were having them enter their homes. They were finding them in appliances, chewing through wires, inside fridges, breaking a lot of things. And they're obviously voracious because of their incisors where they just chew through everything and are obviously competing with one another for food. So stores had all sold out of traps and poison. And it was really interesting to see some of these videos of store owners and people who owned houses saying they would just wake up every day and there would be hundreds of dead mice in the house or in the store, out the front of the store. And there was someone who set up 12 bucket traps around their house and caught 500 mice in a night. And you're just like, this is just insane, but it was a drop in the ocean. It was barely anything, So there was an owner of a cafe who was on the news and had to spend something like $7,000 just repairing their fridge multiple times because the mice kept getting into it and chewing through all the cables and just, killing the fridge. So they had a whole bunch of businesses spending tens of thousands of dollars on just dealing with this plague. Potentially hundreds of thousands of dollars. And one of the biggest ones was farmers who had these crops. And even if they'd harvested already, the mice would just chew through the plastic on the bales of, say, the hay. And each bale is worth about $500. And so in Coonamble, the mayor was estimating that they'd lost something like $40 million, where farmers had lost more than 2,500 bales of hay. It was just getting chewed up. So, it was just really interesting. How did we get mice? We got mice from England. They came over when Europeans got here.
They did.
Probably.
Not deliberately.
No, but they would have been on the ships.
But mice and rats would have come here. And, as you know, being having
the
worked on the rat man. But, European mice and rats would have come out here as stowaways on ships.
Yeah.
Because there will always be mice and rats on ships.
They would have had grain and other food that would have been
exactly.
eaten by those guys. But yeah, they plague due to weather.
Yeah.
When you get a wet winter followed by a wet summer, you get lots of new growth. That's a food source for the mice.
Mm-hmm.
And the mice, Mus musculus, the species of mouse that we have, has evolved to just be incredibly good at breeding and reproducing.
Boom population growth.
Yeah. And so they can breed rapidly. I think one female in a year can have 50 pups.
Yeah.
And that's 6 to 8 mice every single litter.
Yeah, and they would have 6 to 8 litters a year because they can reproduce between 5 and 8 weeks.
Yeah, so that's it. Every 4 to 7 weeks, they can start reproducing. The one she has can start reproducing. And so one female apparently in a single year can give rise to 5,082 babies. And so you can see how it just rapidly explodes.
Yeah, so within a 2 to 3 month period, you could end up with each female mouse can produce 100 in a couple of months. So.
Yeah, it's just insane. And so they'll just keep growing whilst there are resources that are there to be eaten.
Well, yeah, they're effectively their population is resource limited. And normally, in a normal year, those resources are quite shallow and rare because in those areas, again, they're, from a previous episode, we were talking about northwestern Victoria. It's the same region now in terms of it's marginal country. And so you'll have years where you don't get much rain and therefore you don't get much growth of food sources for these animals. But then in a year that you do, it booms. And so, typically you'll have, there'll always be mice there. It's not like they suddenly appear from nowhere. But they simply can't reproduce very much because they starve. But they're not going to starve when the food is effectively infinite for them, particularly when humans manufacture food for them. We manufacture grain and we manufacture grass. And we not only do we manufacture grass, but we cut it down and store it for them in bales.
Beyond that, I think a massive issue is that we've removed the predators that are going to be wiping them out and controlling these numbers. So we're going to have fewer reptiles like snakes that are going to deal with them, fewer predatory birds. You'll have fewer owls, fewer eagles, everything like that.
Small carnivorous mammals that we had up until a few hundred years ago. And certainly a few thousand years ago.
That would have either predated upon them or other herbivorous mammals and animals that would have competed with them.
Yeah.
And so it is one of these arguments where it's important to keep these ecosystems intact, or at least as intact as possible, with other predators and other competing species, to try and not allow this thing to happen. Because like with rabbits, with cats or foxes, when they explode in numbers like this, they can do irreparable damage to the environment, to other species.
When they have no competition and effectively an infinite food source, then there's nothing to control their population. So.
Yeah, and so I remember there being another plague in the past that we'd had that was a big issue, and that was in 93 apparently, and it cost us $96 million in damage.
Yeah, these sort of mouse plagues, I think, come around about every 20 years. Though, and it's that the perfect storm of environmental conditions. And there's nothing we can do about it now, in a sense, because you can't go back and suddenly repopulate, predators and competitors and things in these areas because they simply don't have the food sources either. Particularly when we're looking at either pasture areas or where we've removed all of the trees, the forests and things, and in areas where we're growing grain. These are monocultures, so very few animals can live in those environments. Reptiles do quite well. Mice do very well. Insects do very well, but not much else.
Well, yeah. And in 93, it blew my mind when I was looking this up, some of the ways in which the people were dealing with the mice. Because there were some videos on there of people with just flamethrowers walking around their yards, just I just don't think you'd get away with that today.
No, probably not.
Anyway, farmers were trying to use things like poison, but they were saying it's just so difficult and expensive with the huge mouse numbers, despite obviously probably being dangerous to just be throwing poison around everywhere.
Exactly. And long term, you're making things worse because you're killing off other competitors as well.
Yeah.
So
Well, and that's it. What happens to an owl or a predatory bird that eats a mouse who's died from having mouse poison, which effectively causes internal bleeding, until you die? Is that going to affect them? Especially if they pick up 10 different animals that have died from the same poison. The researchers were looking into this plague, and I think they were suggesting that a preventative measure, or a measure that would at least help diminish the effects of this sort of a plague, would be putting up owl boxes in as many places as possible to try and encourage owls to nest and obviously keep their numbers up. So it's going to be interesting to see what happens in the future with this sort of stuff, and people, instead of, say, trying to invest millions of dollars in using technology like poisons or traps to try and deal with this problem, if they turn back to nature and think instead maybe we can boost the ecosystem,
the predator population,
to manage it itself. And it did, when I was thinking about this and these boom-bust, these plagues that happen with some of these sort of mammalian species, it's interesting to think about. I remember being in biology lectures back when I was doing undergrad and learning about the lynx and the rabbit. And it kind of has this, is it like a sine graph?
Yeah.
It goes up and down and they kind of follow one another. Yes. So when you have rabbits increase in a number, in a population, so, in an area, they go from 50 to 1,000 or something over a year or two. The lynx all of a sudden are like, oh, I've got lots more food, so I'll suddenly have more babies and reproduce more. And then as a result, that starts tapering off the numbers of rabbits.
Yes.
And then the numbers of lynx have to taper off, and it just keeps going in this cycle
you
like
get these sort of time-shifted cycles of sine curves going, increases and decreases in population.
Well, I think we found that in Australia with rabbits, haven't we? There's been studies that have been done on rabbits, and there's these counterintuitive kind of results where I think rabbits are the worst pests we have in Australia in terms of the damage that they do to different species.
Yes, because they do physical destruction to the soil.
Well, they do that, but they also
compete with.
I think it was like 100 different species that they were either eating as plants or that they were competing with. So a big interesting sort of issue is, like we've tried in the past within infecting them with myxomatosis and calicivirus. These viruses, that we thought, I don't know what the death rate was, but it was probably, more than 50% that got it died, right? Yeah. So it would wipe out most of the population. Then they become resistant. But then they become resistant. But the interesting thing, I think, from memory was that studies were showing when you have high numbers of rabbits, a lot of the other pest species like foxes and cats predate on the rabbits and leave the native species alone. And so you have this kind of, what would you say, like unholy relationship, this deal with the devil, where by having a larger number of rabbits now, it's having a positive impact on a lot of species because they're not being as heavily focused upon by introduced predators, whereas when you wipe out all the rabbits, all of a sudden there are still foxes and cats here.
That have to go out.
Like with the lynx and the rabbit thing, their prey is gone, so they focus on other stuff.
I know.
And I think it was the same with eagles. The moment that they wiped out rabbits, I think there were studies showing that we had a reduction in the number of wedge-tailed eagles.
Yes.
So it is...
Well, the irony is that one of the reasons we have rabbit plagues is because for 100 years farmers were shooting wedge-tailed eagles.
Yeah.
So,
and they recently found someone, I can't remember, I think it was in South Australia, who had 100 dead wedge-tailed eagles in their fridge. So they'd just been hunting them on their land, and you're just like, what are you smoking?
Yeah, I know. It's bizarre.
Anyway, so there you go. I guess the last thing to mention here about plagues and rats that would be interesting is that when I was doing my PhD, one of the options I was potentially going to do was, let's see if I can remember the species name. I can't. I can remember the scientific name. Rattus villosissimus. Let's see if I can... Villosissimus. The long-haired rat is a native species of Australian rat. So we have 69, 70 species of Australian rats, and mice and rats are actually the same thing. They're all rats. This is why in Brazilian Portuguese you only have ratus.
Yeah, ratus.
There's no mouse. You just say maybe ratinho, small rat. And I think the technical term would be that it's a mouse if it's under 50 grams, or maybe 100 grams, I've forgotten. But if it's a certain size, they'll tend to just call it a mouse, and it seems cuter, as opposed to rat, which people are like, ugh, gross. Anyway, so there's about 7 species of native Australian rats from the genus Rattus, the same as the plague rat or the, or not the plague rat,
Norwegian black rat.
Norwegian black rat.
The brown
or
rat.
Rattus, the black rat. But this rat was interesting because it goes through those things too. It lives in the desert normally in central northern Australia, and it goes through these plagues when there are periods of lots of rain. And I think it was astonishing. Like with these mice, it would go from a few thousand individuals, which is the sort of normal number that are probably there. And the interesting thing is across their distribution, where they can be found across this entire range when they're in plague proportions, they shrink down to like 3 areas where there are bores with water.
Yeah.
And they live there in these 3 areas across the entire distribution with available water all the time. But the moment that you have 1 or 2 years where I think it'll be La Nina, right? And you would have more than average rainfall in these areas, then you get this growth of grass, the seeds, everything like that. Yeah. And so the rats just go bonkers. And within this, I think it happens every few decades, but it takes a few years to ramp up. It's a kind of compounding thing. So I think it's like over 1 or 2 or 3 years, they'll go from a few thousand of these Rattus vilicissimus to billions of these things across the entire area. And my supervisor travelled through Central Australia in, I think it was 2011, 2012, just capturing these things. And he was like, you could just get out of the car and pick them up because they were just everywhere. And some of the thing that he was interested in looking at the time was chromosomal rearrangements in this species, because he thought Rattus have this weird thing going on, to get into the genetics, where despite them all being very closely related, the number of chromosomes they have, it changes quite a lot from species to species. So that's a big part of their evolution and the way that they obviously...
speciation just by splitting chromosomes.
Differentiate, The number of chromosomes in their DNA, or that make up their genome, differs and changes. I think they're called Robertsonian changes, where you'll just have one large portion of a chromosome just go...
splits off.
Or change or turn into 2 chromosomes. Yeah. So he was really interested, although this wasn't anything we ever did, in potentially looking during these plague periods to see if you sample across the entire area, do you end up finding animals of the same species that have gone through crazy chromosomal mutations that could then potentially be underlying a new species each time.
If they can survive.
Yeah, exactly. If you had these 3 areas that they're normally at, it suddenly explodes and these rats are found everywhere across this region, and one pocket of them ends up with completely different chromosomal rearrangement and then shrinks back to a certain area, but then becomes the main genome type there. And because the chromosomes have changed and rearranged, there's a different number, they can't breed again. Yeah, so he was interested in looking into that.
Yeah.
So that really
that boom and bust speciation is an interesting. That's one of those things I've never thought about.
Yeah,
because 100 years ago,
many numbers, right?
I was an evolutionary biologist as well, but I hadn't thought about that boom and bust thing as a potential
an engine for speciation.
Speciation within years.
Yeah,
this is like a year.
Well, and this sort of underlies the importance, to finish up here, of museums collecting samples chronologically through time. A lot of people, when we were at the museum, were always saying, we already have this rat in the collection. Why do you want to go and collect more rats? Yeah. And a big part of it, especially with things like climate change or habitat destruction or having species that have large distributions over a big area, you want to capture not just the geographical representation of a species at a moment, but the temporal representation. You want to know what they're doing through time, because like this rat, if you found out, okay, we have, a few of these Rattus vilicissimus long-haired rats in the collection from the 1800s when they were first collected in Australia, that's enough. You may find out that if you go and collect animals today that are the same species, at least based on what they appear like, that if you genetically sample them, they could end up actually having completely different genomes. Yeah. And that's going to have an effect on conservation efforts, everything like that. So it was really interesting. That argument my supervisor was always making to ethics committees and to the public of just like, we need to keep collecting. We don't want to collect like crazy. You get 5 animals from one location, but you want to do that on a regular basis to be able to track what's happening to them. Are they bottlenecking? Is the population shrinking a great deal and they're in danger and we need to conserve them? Or is it exploding and they're fine and we can leave them alone? And you don't know that. Or if it's
exploding and then shrinking back to different areas and you get different species, then those 2 things are no longer in a really difficult environmental time able to interbreed. Therefore, they're both endangered. Whereas you look at the population, there's thousands of those and thousands of those. That's enough.
Yeah.
But it's not when you look at them individually. So.
Well, and I did a paper on, that never actually got published, but in my PhD on the, Oralis. This time I can remember this, the species name, but not the actual common name. So let me just get that up. The Hastings river mouse, Pseudomys oralis. And the implication of its population genetics for conservation, because it's found throughout, the central east coast of Australia along the sort of eastern part there where there's a lot of rain, and it's this cute looking mouse because
small
it's small.
rat.
Yeah, exactly. Small rat. But when you do the genetics, I found that there were these two distinct populations. And so if you're going to do something like collect individuals from the southern population and breed them up, you don't want to release them into the northern population because they're not the same genetically, and you would be effectively mixing the two. And, besides losing them...
Or if you're expecting them to be able to interbreed and they can't, then you've wasted your time.
Or you may end up with both in the same place.
Yeah.
But they may also be differently adapted to these different regions. You may have one that's in a drier region, one that's in a wetter region, and the reason that they're genetically different is because they've evolved, despite being recently, the same species, they've evolved or adapted to these local conditions to be able to thrive there. And so that's why a lot of the time these, not just collecting samples, but understanding the genetics and where these populations are is really important for conservation.
Yeah, no, I agree.
Anyway, getting my genetics rocks off here in this episode.
End of lecture.
Thanks for joining us, guys, and we'll see you in the next
everyone.
episode where we're going to talk about T-Rexes. It's going to be awesome.
Woo!
I know. See ya. Alrighty, you mob. Thank you so much for listening to or watching this episode of The Goss. If you would like to watch the video, if you're currently listening to it and not watching it, you can do so on the Aussie English channel on YouTube. You'll be able to subscribe to that. Just search Aussie English on YouTube. And if you're watching this and not listening to it, you can check this episode out also on the Aussie English podcast, which you can find via my free Aussie English podcast application on both Android and iPhone. You can download that for free, or you can find it via any other good podcast app that you've got on your phone. Spotify, podcasts from iTunes, Stitcher, whatever it is. I'm your host, Pete. Thank you so much for joining me. I hope you have a ripper of a day, and I will see you next time. Peace!